Hello, hello. This is us finishing out the synthesis questions from chapter 18 on page 18 of the notes. Essentially in these synthesis questions, we are putting all the things that we know about nucleophilic and electrophilic aromatic substitution together to synthesize something from benzene or a benzene derivative. And often in these, you have to work backwards. And One thing to note about this product is that it's 1,4 substituted. As far as both of these substituents, both a methyl group, an ethyl group here, it would be para-directing, but also a chloro group would be para-directing. To some degree, it doesn't matter which time these different things are put on, but it will matter in later reactions. But one thing to note is that in our product, we have this CH2 that has a double bond in it. And if we look back in the notes, we can't do a Friedel-Crafts reaction to put something like that on there if it has an sp2 hybridized carbon atom. We can only do Friedel-Crafts with an sp3 hybridized carbon atom. We had to make this alkene somehow. The other way that we know, or the way that we know how to make alkenes, is by elimination reaction. We can guess that this is going to be put on through an elimination reaction. And if we had a halogen in this position, it would be able to be eliminated to produce that alkene. So if we step back a step and we get to this benzene derivative here with a bromine in that position, and we were to treat that molecule with a big bulky base like potassium terbutoxide, that's going to do an E2 reaction, deprotonating this position to make our alkene. So that was the desired alkene. But we now have to add a bromine to that position. How do we do that? We learned that on Friday's class. It's with NBS, N-bromosuccinimate, and light. So that was the allylic bromination that we learned in chapter 15, but now it's called a benzylic bromination. If we take that back a step, we would brominate this benzylic position. And in the intermediates of that reaction, we have a radical that's stabilized through this aryl ring. One thing that I see students do from time to time is use this type of condition to put a bromine on the exterior position, like this terminal position. That's not a benzylic carbon there. Only the one directly connected to the benzene ring is benzylic, so NBS puts a bromine just on that position. Next, how do we get these two different substituents on the benzene ring? Well, this ethyl group is going to be para-directing, so if we go back a step and we have the ethyl benzene here, and we treat that with Cl2 and FeCl3, it's going to make a mixture of the para substituted, because this ethyl group is a para ortho director, and it's also going to make some amount of the ortho substituted benzene ring. And it turns out that there's not really a good way around this. So if we want the para chloro molecule, we're going to make some of that, but the good thing is that these two molecules will have different physical properties. So when we make this mixture, we can just not worry about that. We'll get rid of it. That would be done by some type of distillation or chromatography or something, and then we will use this in further reactions. So we're almost back to the starting material benzene. To get an ethyl group on there, all we would need to do is a Friedel-Crafts alkylation reaction. To do that, we would have ethyl chloride and aluminum 3-chloride. And that will undergo the Friedel-Crafts alkylation to put that ethyl substituent on there. So this is the first of the two examples in our notes, and I'll do the other one in the next video. So see you then.